half our coral reefs in the world have already died from bleaching. The algae living inside the coral, giving it its fuel, is unfortunately sensitive to heat. And our oceans have warmed 95% of the ocean of the heat that we've added to our planet from carbon dioxide has been absorbed by our oceans. When the temperature increases by about 2 degrees for a month or 4 degrees for 2 weeks above what the coral are used to, the algae leaves the coral. And so suddenly the coral, which was getting the sugar that the algae made, is not getting any of that sugar anymore. And it's starving to death. And that's called bleaching. The algae takes its color with it. The animal still remains. You can see through to its bones, which its skeleton, and it looks white. It's going to die if the temperature doesn't fall and the symbiosis could be reestablished. It can be reestablished. And that's a really important thing to remember.
Hi, welcome to another exciting edition of Code Green, Conversations for a Future We Want and Our Kids Deserve. This is a real big one. It's about a real big story that has developed in the last couple of weeks. Not news to marine biologist Juli Berwald, who is my esteemed guest, and I'm so honored to have her here. Not news to people who have been following I hate to say demise of coral. I hate to even say dying oceans. The troubled coral reefs, of course, at our hands, human hands, and didn't get a lot of mainstream coverage. Why should, collapsing ecosystems be part of the mainstream news mix, right? When Jeffrey Epstein is still dead. So we're going to talk about the significance of this first tipping point for a coral reef die-off. What does that mean? Does that mean it's irreversible? Is that like 100%? I don't think it is, because I know Julie has been out there working to somehow save coral, restore coral. We're going to hear all about that. I promise you this is going to be upbeat. Julie is one of my favorite guests, and I've done some 5,200 interviews. You'll see why in a minute. She's optimistic, she's animated, and she's written two great books. I love the title. She, as intelligent as she is and knowledgeable on marine biology, she's just as clever and creative. She's a great writer. The first one was about jellyfish, spineless, how to grow a backbone, I think is this tagline. And then the second one, which is all about coral, Love on the Rocks. I love those titles. I love what I have read of your books. I wish I had time to read them fully more, but I highly recommend them. Anyway, welcome to my new video series on YouTube. Great to have you.
Thanks, Betsy. It's great to be here again. Talk to you
Yeah.
again.
So since we last spoke, it's been, I don't know, maybe 3 years, things have gotten worse as far as die-offs, bleaching, but you have not been sitting home crying. I have seen you in all kinds of exciting places and starting or joining all kinds of optimistic programs. But let's just start with, why are coral reefs important to humans? Why should we care when it's something we can't really see?
Yeah, coral are this kind of amazing animal, and I think it's maybe a good place to start by saying they're animals, just like us. They have nervous systems, they have digestive systems, they use eggs and sperm to reproduce. So they're animals like us, but they have this crazy cool superpower, which is that they've made a partnership with an algae, and it lives inside of their gut tissue, and it photosynthesizes. And so it takes the sun's energy with water and carbon dioxide and mixes it together and makes sugar. And that sugar is such an incredible fuel that it has allowed the coral to create those underwater cities that you've, like, if maybe dove on, or if you've been lucky enough to dive, that's fantastic, but even seen pictures of how gorgeous they are. So those coral only take up less than 1% of the ocean's area, but they support a quarter of all marine life. So that's some 860,000 species that we know of. And we have certainly underestimated how many species of animals live in the ocean. And so the corals are really like this disproportionately important animal ecosystem, habitat builder that, its influence explodes out over all of the oceans in terms of ecosystems and biodiversity. But then, like in terms of us on land, 1 billion people get their primary source of protein from coral reefs because we have a lot of people who live near coasts and also who live in tropical places where those corals are. And there is no better storm protection for us than a coral reef, which can diffuse 95% of a storm's energy. So as storms get stronger in our warming world, the coral reefs are just an incredible defense system for us. And so those are just like a few reasons why we should care about coral reefs. They really are disproportionately important to us.
An evolutionary marvel. I don't know if those are your words or I read it in one of the articles.
Yeah,
Yeah,
of course.
that sounds
I
like what
mean,
they are. Life
like
sustaining,
really?
diverse, interconnected, deeply so. I think it was probably you who described coral as like condominiums for so many inhabitants.
Yeah, I mean they're just they're cities. They're complete cities.
Mhm.
So it's they're really an incredibly I mean, also just beautiful part of our planet. And so there's yeah,
Okay,
we should care about them.
let's talk about this. Let's talk about this tipping point and what it indicates, what it doesn't mean necessarily, and then we'll talk about some of the great, hopeful, uplifting, exciting projects that you've been working on.
Yeah, so I think there was one article that was came out about a week and a half ago, I think when you contacted me that said we'd passed the tipping point for coral reefs. Um, the problem for corals is that partnership I told you about, that the algae living inside the coral, giving it its fuel, um, is particularly sensitive or unfortunately sensitive to heat. And our oceans have warmed again disproportionately. 95% of the ocean of the heat that we've added to our planet from carbon dioxide has been absorbed by our oceans. And so when the temperature increases by about 2 degrees for a month or 4 degrees for 2 weeks, and there's some variability around that, above what the coral are used to, we don't know why, but the algae leaves the coral. And so suddenly the coral, which was getting 95% of the sugar that the algae made, is not getting any of that sugar anymore, and it's starving to death. And that's called bleaching. The algae takes its color with it. The animal still remains. You can see through to its bones, which its skeleton, and it looks white. Its tissue is basically clear. And so it's going to die if the temperature doesn't fall and the symbiosis could be reestablished. It can be reestablished. And that's like a really exciting thing to, I mean, that's a really important thing to remember because I'll come back to it in a little while, but it will die if the temperature doesn't fall within, a reasonable amount of time for it to not starve to death. And that will depend on, kind of what kind of health it's in. And half our coral reefs in the world have already died from bleaching. So yeah, so that's old news. We've known that for 5 or 6 years probably already.
You said
And
half of all coral reefs have died, and would that indicate a tipping point? Is that the
Well,
cutoff?
so I don't know. To be honest, I don't know what the tipping point is exactly. Like, what does someone mean by a tipping point? I can tell you, I can tell you about certain species that I believe have hit a tipping point in Florida specifically, and that's another paper that came out on Friday. But this was a paper talking about like our global reefs, and so I think they came up with a number of 1.2 degrees above the temperature levels that would mean that corals reefs could not recover. We hit 1.2 ages ago, so I'm not sure why this paper called like 2 weeks ago the tipping point. Um, but I think the reason is because we are not doing anything to lower our carbon emissions, and it's clear that we're not going to. And 2024 showed us that we're certainly headed way in the wrong direction. The planet is at 1.4 degrees above our industrial average, so like getting back to 1.2 is seems kind of impossible. So I guess that's the reason to declare it a tipping point. I don't know if like it's like that for corals or if it's more like a sort of a more gentle decline. And we're definitely losing reefs on our planet. There's no doubt about that. And we have been.
And
But
if we continue to, because I'm not sure how we're going to cool the oceans when we are at 423 something parts per million of greenhouse gases in the atmosphere, and the safe threshold is supposedly 350. In other words, as you said, we're going in the wrong direction. So how,
yeah,
yeah.
I do want to just make a caveat. Like the most recent ICRS stands for International Coral Reef Society. I think they put out a report, a global assessment on coral reefs about a year ago. And that's really, I think, what a lot of the coral scientists were paying attention to at the time. And one of the interesting things that came out of that report is that there still are parts of the world where the coral are doing reasonably well. And so like and I think it's important that we get this word out there too. Like we need to, yes, we need, there's no question, like we're the way we're going with climate change is a problem, huge problem. But we also need to understand that all is not lost, even if we've like hit some sort of policy tipping point, or I don't, like behavioral tipping point. Like the coral biodiversity on our planet is concentrated in this area in the Pacific Ocean that's called the Coral Triangle between Papua New Guinea, the Philippines, and Indonesia. It's a roughly a triangle. And there's the most diversity of species exists there. And the corals in that region have bleached, but they've recovered largely in most places, and they're actually doing okay. So, like, we need to recognize there are some places where the corals are still doing okay, and not great, but okay. And so, in the Great Barrier Reef, we've seen some recovery of some of the more weedy species of coral, but nonetheless, they're coming back and they're making habitat for animals. So, like, there's 800 species of coral. And so that's a huge diversity that we have available to us to like say some are doing better, some are doing worse. Like most are doing worse, but there's still some. Like I hate to just say all is lost. So
Remember interviewing David Guggenheim, the ocean doctor, and he did a book,
yeah,
I believe, on the coral in Cuba, around Cuba,
yeah,
and
yeah.
how that is pretty pristine. Tell me if you know an update on that. And is that because there's been so little development in Cuba? Would that have anything to do with it? Or what is the reason? I'm sure he told me, but that was a few years ago.
Yeah, and I actually just was in touch with some scientists from Cuba, but I don't have a good answer on the most recent status update from Cuba.
Mhm.
Um, I'm happy to tell you about like some really interesting stuff that's going on in Honduras where I've been working.
Mhm.
Um, if you want me to go down that pathway a little
Absolutely. Yes,
bit.
give us
Okay.
some real world hope, please.
Yeah. So basically, I think maybe to kind of go back to the news um the news point on right now. So on Friday, there was a paper out in Science. I can share it with you guys so you can see the headline of it. Heat-driven functional extinction of Caribbean acropora corals from Florida's coral reef. So these are the acropora corals are really the branching corals, not like the brain ones or the boulder ones or the pillar ones, but the branching ones. They're really the ones that made up the backbone of the coral reefs around the world. And especially in Florida, there's two species of these corals in Florida. For the last half a million years, they dominated the Florida coral reef, which is 380 miles of reef. And they were really like they were jungles of these two acropora corals. They have been slowly declining, declining, declining. This is what they look like. So they're sort of like what you remember corals looking like. You can see how they bleach. This is the white that you're seeing, and then they die if the temperature doesn't fall. In 2023, there was a massive heat wave in Florida. I'm not sure if you remember that, but
Yeah.
all the coral scientists do. And so basically, in all of these little graphs, that's like the heat from in the summer heat. And the gray lines are like the historical values of the temperature, and these are sorry in Celsius. This 2023 year, which is in the maroon, was higher basically than any other year throughout the entire Florida Reef tract.
Mm.
And so it was mass death of coral. And so they went out and they studied. So here we are again looking at the same region. And T1 was right after that in like October of 2023, and this T2 is in April of 2024. And this is the mortality of these Acropora species. And you can see in the dry tortugas 100%, the lower keys 100%, the middle keys 100%, basically 100% in the upper keys. Biscayne maybe 95, and up near Miami, they had a little bit of better survival around 40%. But the way that the currents go in the Caribbean, they go north. So basically, these guys, even if they've survived, they're not in good shape, and their eggs and sperm will be shoved off into the Gulf Stream. And so there's no chance of recovery for these two species that were the backbone of the Florida coral reef community for the last half a million years. So in terms of tipping point, I would say, yeah, this like 2023 was a tipping point for these two species. And we should know that like some of the most majestic animals on our in our oceans are gone and they're blinked out. So I think that's a major tragedy. I do agree with you that like our news just has not reported that. And there's probably no way to restore this with these corals that, I mean, there are these corals that live in what are called biobanks or basically like Noah's Arks in tons of aquaria and zoos have jumped in, pulled corals out of the ocean to keep them from dying during this massive heat wave in 2023. They have done heroic work with almost no money, no funding, and they've really kept so the genetics exist. So basically, what happened was after I wrote my book, Life on the Rocks, about the coral reefs, this guy from Honduras reached out to me and he was like, hey, you got to come see my coral reef because it's really healthy. And I was like, there's just no way. And so here, maybe I'll share a screen again. And I went down there. This is where it is. So basically, yeah, so here's Honduras, and we're on the north coast of Honduras, and it's a big giant bay. And it's literally where the Banana Republic started. The old docks are still in the bay. You can see them where the banana boats took the bananas away for starting in 1910. There were there still are massive banana plantations in this area. And so this area has been polluted for over 100 years. And maybe that's part of what's going on. But when I went in the water, I was like, what is going on here? Like, this looks like a reef from the 1970s. And see this coral here in the top corner?
Yeah.
That's the one that's now extinct from Florida.
So
And
if it's that yellow brownish color, is that good or bad?
that's the algae that is giving it its food. And this is it too. It's called a cropper palmata. It's the elkhorn coral. There are kilometers and kilometers and kilometers of this coral living perfectly happy here in Honduras. So after I saw this, I was like, why is no one studying this? This is crazy. And I started talking to everyone I knew. And I ended up talking to this guy named Dr. Andrew Baker from the University of Miami. And I said, you got to go check it out because the Acropora palmata, the elkhorns are like happy as could be down there. And the ants, and I mean, loads of others. There's like at least a dozen critically endangered species in this on this reef that are, it's a mystery. And it hadn't received any scientific attention. So eventually, yeah, this one is like, again, critically endangered or endangered, probably critically endangered now. And it's like the size of a house. We call her casita. These are palmatas that I was telling you about that are just everywhere and beautiful. So I started this nonprofit to get the word out. Basically, we found there were like babies being born on the reef. These are coral babies. We put down these tiles to catch little babies, and one of the amazing things is that corals aren't really making babies in a lot of the Caribbean anymore because they're so spread out. They can't, the eggs and sperm aren't meeting, they aren't settling, they aren't. But we found all babies, and this is what a baby looks like under ultraviolet light. They glow. And it was just it's been a lot of fun to get to the Andrew story. I told him about it. He eventually managed to get permits to go down, took back to Miami about a dozen colonies of the elkhorn. Amazingly, they spawned a month later, and they bred them with Florida elkhorns. And so they have these little babies now. They're called flandurins. And what's really crazy is that Andrew figured out that the algae that lives inside of the coral in Honduras are a more thermo-tolerant species than the algae that lives inside the coral in Florida. And this more thermo, it's called Durstinium. And so we've known about this more thermotolerant algal species for a long time, and we could get the corals in the lab to form a relationship with them, but when you put them back in the ocean, they spit them out. But in Honduras, Intella, maybe because the water's been polluted for longer, maybe because it's warmer, but they naturally have this association with this more thermotolerant species.
Hmm.
And it turns out the Flanders do too. The babies that are half Honduran have the capacity to keep these more thermotolerant algae in them. And so in June this year, we got permission for the very first time in the world to plant these Flanders, so like a cross-national gene to go back in the water. So we planted 60 of these little nubbins. And actually, on this little disc, there's two Flanders and two straight up Florida Alcorns. And then this was a little like predation protection device they put on it, right away so that it could get established. They made it all through the summer. They did not bleach. They're still growing. And so it's a really, really successful pilot study. And, if we want elkhorns back in Florida, we might have to import these genes to help them make it through the heat.
So
So, yeah.
this is an example of geoengineering actually being a big plus.
I mean,
Okay.
I guess it's more of a biological engineering. I mean, it's really just a translocation. We've done this with crops forever. We've done it on land. We've brought over different species that we've wanted in different places, birds,
Mhm.
loads of plants. But in the ocean, we have such strict regulations that this was the first time it's ever been allowed anywhere in the world. And at the same time, like I said, there are no more elkhorns left in Florida. So it's it's just a crazy the reason that had always been given is like we don't want to pollute the gene pool of the Florida elkhorns, but there's no gene pool left. I'm of the opinion that we need to even, I mean, move faster with trying to find corals that could replace those that are missing. It's an ecosystem situation. I mean, the amount of suffering that's going on by the animals that rely on that ecosystem for survival is enormous. And so there's sort of an ethical reason to do it as well. So we'll see what happens now. This paper that came out on Friday, like it kind of cleared the path for us to try. I mean, maybe it cleared the path for us to try things that we haven't been allowed to try before.
And
So,
I want to get to the funding of these efforts in a moment, because that is, I think, a little more upbeat than you might
yeah.
expect, as it should be, of course. It is an emergency. But I want to first talk about the sex lives of corals, because you said they're sexual and asexual. How can that be?
Yeah, they have eggs and sperm. They release them. Every species is a little bit different, but basically they release their eggs and sperm once a year in the hottest month of the year. It's like a reverse snowstorm that everything's floating up, and they're sort of pinkish white. So it's like, yeah, it's like everything's, and then they have to meet each other. They form a little larvae that looks like a grain of rice. It settles back down on the reef and tries to find a good home, and then it grows into a coral. So that's the sexual way of reproduction. It's really amazing because each species sort of has its own time slot. So like it's based on the full moon and the sunset. So like basically in July, 3 days after the full moon, 2 hours after sunset, one Orbicella favulata will release all of its eggs and sperm, and then one day after the full moon, another species will do it. So it's like it's just this incredible, yeah, brilliance that the corals have to
Dance of
like
nature,
have,
miracle of nature.
yeah, they have these timers that we're like just figuring out, just starting to be able to figure out what their timing mechanisms are, but they all know it. And so it's really cool. And then yeah, I mean, especially the acroporids, the branching corals, they're really good at being broken, cementing themselves back onto whatever the reef they find themselves on and then growing again. And you can see it in Tella where there's these jungles of elkhorns, the waves, boats, unfortunately, will break pieces off, and they just cement themselves back and then start growing brand new colonies. So their sexual reproduction, I mean, asexual reproduction is a really, really important, especially for these branching corals.
Mm. So love
Yeah.
on the rocks, you're talking about the sex lives of coral, like you talked about the sex lives of jellyfish, something we should all know about, right?
Yeah, it's not too different. Jellyfish and corals are first cousins. They're in the same phylum, Cnidaria. This is a coral colony, and you can see like it's kind of like a jellyfish in that it has these tentacles, right? And that this is called a polyp. A single one is called a polyp, and then that's its mouth. So it's basically like if this is a jellyfish, it has like tentacles, it has a mouth underneath. So this is a jellyfish flipped upside down, and then it's formed like a colony. It's made up of a bunch of these. Like I said, because of that incredible, here we can look at it. If we look at inside, here's one of those polyps again, and you can see inside these beautiful golden sort of orbs. That's a close-up of it. That's the algae. That is kind of its like superpower, solar power that gives it all its food.
So when you see like the skeletons, the graveyard, the white coral, that means it's been bleached. Is there any way to bring that back? And what are the most promising geoengineering techniques that are being studied? And I think I saw that 3D printing, like making an artificial reef, may hold some hope.
Yeah, this is what a bleach reef looks like. So you can see it's gone. No, once it's, I mean, well, this one may not be gone, but looks a little gone to me. It will die if it doesn't cool down. This is what a dead reef looks like. I think you know that.
It looks
This
like a
is a dead.
graveyard. All right.
Yeah, great. There's some really cool ideas out there around restoring coral reefs. This is actually in Indonesia, in that coral triangle I talked about before. The bleaching is not is well, it's bad, but it's not horrendous. But this is from blast fishing. This is the result of blast fishing, which is when you people fish by throwing a bomb in the water, which stuns the fish. They float to the surface, and it's easy to collect them. It's illegal, and probably actually the United States played a role in its popularity spreading during World War II when there was a lot of munitions around. But it's pretty common when I was diving in Indonesia, I would hear it once or twice every dive. This is a really exciting project. I don't think this is really counts as geoengineering as much as restoration. But this is the Mars Candy Bar Company has created these, it seems like it's really simple. It's these rebar structures, and they tie the corals onto them. Fishermen are paid to do this, and then they snorkel them down. They network them together into a galaxy of reef stars, and then 18 months later, you can get this kind of restoration. And then 3 years later, it can return. So this is the kind of thing that gives you hope. And again, these acroporids in the Pacific, there's 128 species of these acroporids. So there's kind of an idea that was at one point considered really radical to bring these corals from the Pacific to the Caribbean, which is maybe less radical now that we know there are no more acroporids left in the Caribbean.
It seems
Um,
overwhelmingly complex, and if it works on a small scale, then how do you scale up across the oceans, the vast oceans?
That's right. I mean, even the Great Barrier Reef alone is the size of Italy. So doing these kind of, yeah, patch restorations works, but the question of scaling up is a really big one. And actually, the people who are doing the most work on that are in Saudi Arabia.
Hmm.
Um, and they have committed to building 100 square kilometer artificial reef rest. So, and they're, I think, making good progress. I mean, they have the money to invest in it. And so they're building like the biggest coral restoration sort of factory known to
Saudi
man.
Arabia. That's ironic since they're a big exporter of oil. Um,
Exactly. Yeah,
cause
but yeah, but they're also kind of making huge leaps forward in the coral restoration world. So
maybe
I don't
it's a
know.
guilt offset, but keep it coming, right? I know that in reading one of your chapters or articles, you mentioned that there is funding, that like there are some people like X Prize that are, and Tom Moore, I'd like to hear a little bit about him. People who are saying, we need to get going. We can't just discuss this forever. If we wait, we're not going to have any options if we just deliberate. And what is in the works now? Are you getting some funding? Is it widespread enough to really make a dent?
So Okay, Tom Orr, it's interesting you brought him up. He actually moved to Saudi Arabia to help work on that project, the big one, the 100 square kilometer project. At the end of when I was finishing up the coral book, there was this big push for the United Nations Global Fund for Coral Reefs, and they were trying to get like $500 million for that, and it has not. I think there is some money in it, but it hasn't really been flowing. One of the biggest projects is called CORDAP, Coral Reef Accelerator Program, and they have been giving $1.5 million funds to different projects around the world, and that has actually been more money that has come into coral reefs than really anywhere else. So that has been sort of amazing, and there have been projects around the world based on that. For us, yeah, the nonprofit. Well, let me. I didn't finish talking about geoengineering. Do you want me to kind of
Yeah.
mention that real quick?
Yeah, and
So,
also a little bit more about Tom Moore. How did he become such a coral saving funder? Just kind of
well, he got hired by the Saudis to oversee that project, and so he
because he was
decided.
already an expert, but how did that happen? Is he a scientist or
Yeah, yeah, he
guy
went to.
who wanted to do some good? What's his story?
I think he was excited by the idea of doing a big, huge project, the biggest project in the world. He had been working at NOAA in the United States, and in the on the Florida Reef, he's an innovative thinker. He came up with this idea for like restoring 7 iconic reefs in Florida, and had been trying to. Yeah, I mean, part of this is I think you brought up at the beginning the reefs are so invisible that it's really hard to get people's attention. So part of it has to be almost like a storytelling branding story. I mean, the and Tom was just excited about the idea of doing a really big project. And so he decided to go for it and move to Saudi Arabia and make that happen.
Fabulous. And so what else do you want to say about geoengineering before I
Yeah,
get
so
to the last couple of questions? I could talk to you all day, of course. You have
Yeah, so in Australia, they have a big coral restoration project, and one of the things that they realize is like their reef, like I said, is the size of Italy. So they need more than what you're saying, like these point projects that like what I showed you, the restoration project. So they, what heats up our planet is oopsies, is the sorry, is the sun. And one way to block the sun is by using clouds. And there's this thing called marine cloud brightening, which is to add sea salt to the clouds and you bounce solar radiation away. And calculations have shown that we could decrease the temperature underneath those set clouds by as much as like 2 degrees Celsius by adding sea salt to marine clouds. Marine clouds are not as bright as land clouds. And so they've been doing this is actually would count as sort of geoengineering if it was done on a global scale, but they're doing it on a regional scale. And they're taking seawater, aerosolizing it. The salt crystals are 1 micron big, so like the size of a bacteria, and they float up into the clouds and they make those clouds sparkly, more bright, and they reflect solar radiation back to space. And they've actually calculated that it could work to cool the Great Barrier Reef, at least during heat waves. And so this is kind of like the biggest scale project that's going on right now, and it's pretty cool. It's really exciting.
well,
Um, yeah. And I will tell you, wait, hang on. Yeah, so that's that on geoengineering. And then wait, there was one other thing that I didn't finish telling you about. Anyway.
well,
Um,
3D printing. I mean, should we know a little bit more
oh,
about
3D
that?
printing. The 3D printing thing is interesting, and I think it could be really important, especially like there's projects through the defense DARPA, the Defense Innovation Department, to create like seawalls because, like I said at the beginning, corals are the best line of defense against storms. So you could create the idea there is sort of like a hybrid living, non-living storm structure that if like the corals got knocked off during a storm, they can grow back. They can heal themselves basically. So it's like an underwater barrier that can heal itself. And so there's some interesting work going on around that. Um, there's also, yeah,
If we don't screw it up too much.
yeah, I mean, there's definitely failed structures that people have put in the ocean that don't grow coral and end up being kind of debris on the seafloor. So there are things to be concerned about.
Okay.
Um,
I understand mangroves, like how that helps protect coastlines in storms, but just say a couple more things about how coral, so tiny, at the bottom of the ocean, I think, can actually help be a barrier for storms.
well, coral tend to live just offshore from the land, right? So they're little ways offshore, and then it's like their rugosity, their yeah, the structure itself, can just act as a barrier, but not a solid wall. Like a wall will act as a block, and then you get erosion underneath, and all kinds of weird things happen. But basically, I mean, it's like, if you put your hand outside the car window, and if you put your hand like this, the wind pushes, but if you go like this, it kind of can, you can feel it like going through your fingers. Well, basically, that's what a coral reef can do to protect against the coastline is just like break up the energy,
Oh,
um,
even
and stop
small.
it from,
Yeah.
yeah, yeah, break it into little pieces, I guess is the way to say it. I'm sure I screwed that up, and if a physicist heard me say that, they would.
No, it's enough of an explanation for the lay
So,
people among us. Okay, quick question about OPR. I don't know if you have an opinion on ocean pasteurization restoration, if that's what putting sprinkling iron into fisheries to help them
oh,
come back. I know someone who's very big on that, and I just wonder if you have
oh,
if you don't have
interesting.
an opinion, that's fine too, because I do have one more question.
I do, yes. I mean, I know a little bit about it, but my information's a little bit old. If you put iron in the ocean, iron tends to be like something that the phytoplankton in the ocean are missing. So if you sprinkle iron in the ocean, you can get a phytoplankton bloom. That's photosynthesis, so it pulls down carbon dioxide, and then the bloom will sink to the bottom of the ocean and sequester that carbon. So, like in theory, it's been around, the idea's been around since the 90s at least. One thing that we notice about it is that you tend to get a community shift. So you'll see that the kind of phytoplankton that grow in response to iron fertilization changes, and that may have, because they're the base of the food chain, that can have an impact all the way down the food chain.
In a positive or negative way or both?
I don't know, it can have an impact. And you could change the kind of baby fish that then would eat those plankton and then grow up, or maybe the fish that need the food wouldn't have the food there. So, need to be a little careful about doing that sort of thing.
Yes, geoengineering, is such a scary word for so many, but my one of my last recent interviews is with Bruce Melton, who's
Hmm.
you must know him because he's in Austin, environmental
Yeah,
engineer, climate geek genius, and he says, geoengineering, that's what we're already doing to our planet, and I guess
one hundred percent.
that goes for the ocean as well as the atmosphere.
100%. We are.
Okay, so last question. I could go on, but got to keep it just a little bit more, and then I'll let you go. What about plastic? We hear so much about microplastics, plastics in the ocean. Do they have an impact on coral? And if so, how much? And then my last question will be, what can we, who are concerned, do about it?
Um, yeah, I mean,
Everyone should be concerned, people. Come on, wake
yeah, plastic is nasty, and we should, in the ocean, it does nothing good. So we definitely need to be aware. I think focusing on coral reefs and plastic is maybe a little bit of a red herring. The biggest contributor to plastic in the ocean is discarded fishing gear. So, like, I, I, I don't know, like, no, we shouldn't be throwing plastic bottles in the sand. And yes, we need to make sure that our plastic is responsibly taken care of. But honestly, if we don't take care of the fishing gear problem, then that's the
Is that
source of.
being addressed at all? That's probably a big question to end with, but since I have heard that over and over again, are there new regulations or are they being followed if there are to address this?
Yeah, so that there was just a new law of the oceans passed, and I'm not 100% sure if it's ratified yet, and I don't think the United States signed on to it.
Person.
Um, so I think there's a lot of efforts towards that, towards in that direction, but I don't, I couldn't answer with any certainty on that question
All
right
right.
now.
Let me just ask you, Julie, thank you so much for your time. Dr. Berwald, what would you like us to know that we haven't touched on yet?
Okay, this is like super fun, but um, so I found Honduras because this guy read my book and reached out to me. Well, another guy read my book and reached out to me, and it turns out he is a musician, a classical musician, and an composer. And he's created a whole show called Music for the Ocean. And we're performing the show. I should say this. Hang on, let me share one more second. Through the nonprofit I started, we were able to buy this piece of property in Honduras to protect these crazy coral that have this rare symbiont that, well, not rare, but unusual for coral symbiont that allows them to handle temperature better. And we were able to buy this land through donations, which was incredible. And now we need to build the first marine biology lab in Honduras, on the mainland of Honduras, for this. But we've already started collecting these corals, which are really susceptible to a terrible disease that's going through the Caribbean. So we're calling that our biobank um, phase one. These are maize corals, and we're having these tanks manufactured in Guatemala right now, and they're going to go on this property, and it's super exciting. This guy Chad reached out to me, and we're doing this concert called Music for the Ocean. It is stunning. I'm going to show you. This will cheer up your day, regardless.
You're okay. Stay tuned for the good news, and you will never find a better explainer of what's going on in the ocean with coral and jellyfish and beyond than Julie Berwald.
Okay, I'm
I
going to share my screen again. Okay, this is an excerpt of the concert. It is based around every piece has is focused on some idea around the ocean or some animal. This is about bluefin tuna, and this is Hui Wu on the piano, Chad Cannon on the violin, and the animations are by Tim Roach, who is a Grammy Award-winning animator. Can you hear it?
Bravo.
So come to one of our concerts. We're doing concerts all over the United States. Bring us to one of your cities if you want to do it. We're raising money for this really important choral. And yeah,
How can people
that's
reach out
something
to
you can do.
you, Julie, if they're interested in learning more about your work? Your website, is that the best?
Yeah, juliberwald.com, and it's just juliberwald.com or telecoral.org. And we're really active. We post a lot, and or you can get on our newsletter and we'll get in touch. So
Love on the Rocks is her excellent book about coral reefs, and she's a rock star. So nice way to end. Thank you so much. You're
thank
never,
you.
never dull, always informative, and actually, even though this is really scary news,
It's scary news, but like I said, it's not over. So
no, we can't give up. I mean, I know you have kids. I'm a grandmother since I last interviewed you. I have a
yeah.
almost 2-year old, and she's the cutest thing in the world. And my daughter, they're hoping to have another one, and I have such joy and such concern, obviously. It's a lot of cognitive dissonance for so many of us, parents and beyond. And what we're doing now, a lot of it could very well be irreversible, which is why we all ought to pay attention yesterday. Thank you.
Yeah. Yeah.
Okay.
Thank you. Thank you for all you do
Thank
and getting the word out.
you. I will continue to, as long as you're out there, I will not give up. You give me hope.